With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello guys, we have which of the following functions defined below are continuous at the origin. We have given four functions fx, gx, hx and px. Now let's say first of all we have a function that fx at x is equal to a. Now it is said to be continuous if LHL means left hand limit is equal to right hand limit is equal to f of a. Now we have to find continuous at the origin. So this means LHL means left hand limit is equal to right hand limit is equal to f of 0. Now first of all we solve first part, that is f of x at f of x f of 0 f f of 0 its value is 0, so we can say that at f of 0 it is 0. Now first of all we will find LHL means left hand limit is equal to limit s tends to 0 f of minus h, this is equal to limit h tends to 0 minus h into cos of minus 1 upon h, and we know that cos of minus theta is equal to cos of theta, so this can be written as limit of h tends to 0, we will take this minus sign outside, h into cos of 1 upon h, and if we put the value of h, that is 0, so this is equal to 0. Now similarly if we find right hand limit is equal to limit h tends to 0 f of h, this is equal to limit h tends to 0 h into cos of 1 upon h, and if we put the value of h, that is h tends to 0, so this is equal to 0. So from here we can say that LHL equal to RHL equal to f of 0, so this is continuous, so this is continuous. Now similarly if we solve second part we have g of x at x is equal to 0, g of x is equal to 0, so this is at x is equal to 0, at g0 it is 0. Now if we find the value of LHL, we will take LHL, that is equal to limit of h tends to 0 g of minus h, this is equal to limit of h tends to 0 minus minus h raised to power 8 plus minus h raised to power 4 plus 2 into minus h raised to power 2 upon sine of minus h. Now we have a property of sine, that sine of minus theta is equal to minus of sine theta, so this can be written as limit h tends to 0 h raised to power 8 plus h raised to power 4 plus 2h square upon minus sin h. Now here if we multiply and divide by h, so this is equal to, now if we separate terms, this term is equal to 1, so this can be written as, and if we divide h raised to power 8 plus h raised to power 4 plus 2h square by h, so this is equal to limit h tends to 0 h raised to power 7 plus h raised to power 4 plus, sorry guys, this is h raised to power 3 plus 2h. Now we will take this minus sign outside upon 1. So if we apply limit, so this is equal to minus 0 plus 0 plus 0. So this is equal to 0. Now simply if we find right hand limit, this is equal to limit h tends to 0, g of h, this is equal to h raised to power 8 plus h raised to power 4 plus 2h square upon sin h. Now again here if we multiply and divide by h, so we get, from here we can say that its value is also 1. So this is same as this expression, and limits are also same, so its value will become 0. So this is equal to 0. So from here we can say that LHL is equal to RHL equal to g of 0. So this is also continuous. Now if we solve third part we have hx at x is equal to 0, h of x is 0. So we will put the value of h of 0, that is equal to 0. Now if we find the left hand limit, we get left hand limit, this is equal to limit. Now we will take another variable, because we first of all we have h variable, so we will take another variable, that is t tends to 0, h of minus t, this is equal to sin of minus t into cos of minus 1 upon t. And if we apply the rule of sin of minus theta and cos of minus theta, so this is equal to limit, sorry guys, here I forgot to put the limit t tends to 0. So this is equal to limit t tends to 0, this is minus sin t into cos of 1 upon t. Now we will take this minus sign outside and here multiply and divide by t. So this is equal to minus limit t tends to 0 sin of t divided by t into cos 1 by t. Now we know that its value is 1, and here if we apply limit, so this is equal to 0. So 1 into 0 is equal to 0. Now similarly if we find right hand limit is, this is equal to limit t tends to 0, h of t is equal to limit h tends to 0 sin of t into cos of 1 upon t. Now here if we multiply and divide by t, so this is equal to limit h tends to 0 sin of t into t upon t into cos of 1 upon t. Its value is 1, and here if we apply limit, so this is equal to 0. So again its value become 0. So from here we can say that left hand limit is equal to right hand limit is equal to h of 0. So this is also continuous. Now if we solve fourth part we have p of x at x is equal to 0, and we have given that p0 is equal to, sorry guys, here the value is, here minor mistakes, here not x, it is 0. So we have given p of 0 is equal to 0. Now again if we find the value of left hand limit we have limit h tends to 0, p of minus h is equal to limit h tends to 0 minus h into ln of cos minus h upon ln of 1 plus minus h square. Now here if we solve this, so this is equal to limit h tends to 0. We will take this minus sign outside, h into ln, and we know that cos of minus theta is cos theta. So this is cos h upon ln 1 plus h square. Now here if we put the value of h is equal to 0, put h is equal to 0. So this is equal to, means if we apply limit here, we get minus, this is 0, whole term will become 0 upon ln 1, and ln 1 is equal to 0 by 0. So this is in the form of 0 by 0. So here if we apply L Hospital rule, this state that limit h tends to 0 fx upon gx, this is equal to limit h tends to 0 f dash x upon g dash x. So if we apply this rule, this can be written as minus limit h tends to 0. Now if we differentiate numerator, so again by using chain rule, so this is equal to h upon cos h, and differentiation of cos h is minus sin h plus ln cos h upon 1 upon 1 plus h square into differentiation of h square is 2h. Now if we solve this, this is equal to minus limit h tends to 0. From here if we divide this h by h, and we will take this 1 plus h square in numerator, so this is 1 plus h square by 2 into h cancel out, so this is equal to minus 10h plus this is equal to ln cos h upon h. Now here if we separate terms, we get limit, we are multiplying this sign inside this bracket, limit h tends to 0 1 plus h square by 2 into limit h tends to 0 10h minus ln cos h upon h. Now here again if we apply the value of h is equal to 0, so this term is in ln cos 0 is equal to 1, ln 1 is equal to 0 upon 0. So this is in the form of 0 by 0. So here if we apply again L Hospital rule, so this is equal to, in this term apply L Hospital rule. So this is equal to limit h tends to 0 1 plus h square by 2 into limit h tends to 0 10h minus 1 upon cos h 1 upon cos h into minus sin h upon 1. Now if we apply limits, we get, here if we apply h is equal to 0, so this is 1 by 2 into tan 0 is equal to 0 plus, now minus minus sign, and sin h upon cos h is tan h, so this is also 0. So this is equal to 0. So we get LHL is equal to 0. Similarly, if we find RHL, this is equal to limit h tends to 0 pH is equal to limit h tends to 0, h ln, sorry guys, ln cos of h upon ln 1 plus h square. So this is same as this term, and limits are also same, so its value will become 0. So from here we can say that LHL is equal to RHL is equal to P of 0. So we can say that this is also continuous. Now if we check our options, from here we can say that our option number A, B, C, D, all four are continuous at origin 0, at origin. So, and I hope you guys like it. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.